Hey, Trick Class, let's look at the section 7-8 notes, phase shifts. So this is when we have a left to right adjustment in our curve. So it's not just the sine always starts at 0 or cosine is at 0, 1. You know, the high and low points, now we may shift it over to the right or to the left. And that's what we're doing in this video. All right, there's the different types of functions we're going to look at. Sine curves with sine, cosine, tangent, all these different models where we have an adjustment to the period, right? That's the A, or the W here times the X, adjustment to the amplitude, and then a vertical shift. We've seen those before, but now this is the new one. This is what we refer to as a phase shift, when we're subtracting something from the X coordinate inside the trig function. That's going to shift everything left or right. So here is a little calculator made in Desmos. Again, you can't use Desmos on the midterm and final, but I think it's great for the visual component of the course. So what I have here is A is 1, so that means 1 times sine. B is 1, so 1 times sine of X plus 0. So this is just the sine of X plus 0. This is just the sine function. So you can see it goes through the origin. It has a peak at pi over 2, 1. So there's those key points that were on a single graph, single period of the sine function. So this is just the unaltered sine function now. And we've seen that when A is positive, it makes the amplitude bigger. So those, think of those x-intercepts as like nails, and it doesn't go, nothing happens to those values. But now we're going to stretch the high and the low points up and down by whatever this value of A is. So it gets stretched out higher, right? It goes lower. It can be less than 1. All right, we can flatten this thing out towards 0. But then if we dip into the negatives, it's the sine function starts falling before it rises. So again, there's just the amplitude. It's just the height of that wave, right? And we've also seen B affects the period. So the bigger the value, we're multiplying the angle. Think of X as the angle from the unit circle, and we're multiplying that angle by bigger numbers. So it's sending us through the circle faster. And so one period is taking a lot less time to cycle through there. So if I made B equal 2, you can see these key points when I make myself all the way through one period. Now it's only pi. So instead of 2 pi, it's 2 pi over 2. And it's reducing it down, right? I can make it be like 3. And now I'm making it all the way through one period in 2 pi over 3. Right? It's just taking 2 pi, the typical period, and dividing by whatever that value of B is. So that's the period. That's how fast we get through a sine wave. All right, but and then D was that midline shift. So we go up and down. So whatever, like if I did Y equals D, I'm going to dash it just because, again, it's not technically there. So I'm dashing it. So that is, where our midline shifts from. So instead of us leaving 0, 0 and rising up to this number, now we're leaving 0, let's do negative 1. Or rising up to this number. All right, let's make A be 2 here. So we're going off the midline. We're going up 2 to 1. We're going down 2 to negative 3. That's still a period. It's still going between 0 and 2 pi. It's just that we have adjusted where we're starting from and leaving from. Right, we're just at that midline. And I'm going to bring that in. And so the last thing that we haven't talked about, the last thing that we haven't done yet to the sine curve, is to adjust, shift it left and right. So instead of it always containing the origin, if I change C, you can see this graph will start to shift left or right. And that is what we call a phase shift. So instead of that midline intercept happening at 0, 0, now it's happening at 9.70. Okay, now we're just going in the opposite direction of our sine. So that's called a phase shift. That's just a horizontal shift in the sine or cosine graph. All right, when you see this, this is just because these are accessible PowerPoints, so it writes everything out in symbol instead of symbols. So A sine, this W is technically the Greek letter omega, so that's where that omega is coming from. And then phi or phi, depending on how you want to pronounce it, is that symbol right there. So we are just typing out in words for whatever reason those symbolic meanings there. All right, A is the amplitude, the period is 2 pi divided by that omega, or that W, and then the phase shift is what we subtract in the parentheses divided by that omega. Okay, if this is a negative number, then we go to if we end up with this ratio right here being negative, that's actually going to go to the right. If it's this ends up being positive, we're going to go to the left. All right, so let's see what happens with this one. So, like I said before, the typical period is from 0 to 2 pi, okay, with pi in the middle and then pi over 2 and 3 pi over 2 as those quarter and 3/4 points. So what we're going to do is we're going to set whatever is in the parentheses equal to these numbers, equal to 0 and equal to 2 pi, and then solve that equation, and that will tell us where 0 goes and where 2 pi goes. So if I set 2x minus pi equal to 0, and that's this 0 right here, and just do the math, move the pi over, divide by 2, I'd have x equals pi over 2. So what that means is this starting point is now, instead of it being here, it's going to be shifted over here to pi over 2. That's our phase shift. It went to the right, pi over 2 units. All right, and then the same thing, if I did 2x minus pi equals, now I'm doing the right end. So 2x minus pi equals 2 pi. All right, adding pi over would give me 3 pi, and then dividing by 2 would give me 3 pi over 2. And so 3 pi over 2 is where this right end is going to end up. So that means that we have to get through the entire sine wave in between this little window. Right? What's the gap here? From pi over 2 to 3 pi over 2, that's pi units. You can see there's a 2 in front of the x. The period is 2 pi divided by that number in front of x. So 2 pi divided by 2 is pi. You can see we have a period of pi here now. Right? But we shifted off. We're no longer at 0 on the left end. We're at pi over 2 on the left end. All right, so that's the way that we're setting this up. This is the the left end number that was 0. This was the right end number. It was 2 pi. But because the inputs are these values, this is my new left end and my new right end. All right, there is no vertical shift. I'm not going up or down, so the midline is still the x-axis. So that means I'm going to start at 0. I'm going to come back and land at 0. All right, the average of these two halfway between pi over 2 and 3 pi over 2 is, this is 1 pi over 2, 3 pi over 2. Halfway between would be 2 pi over 2, or just pi. So there is my middle point, the average of those two. It will also be, again, for sine, it's also an x-intercept. This is positive, so remember we initially rise the sine function, so we're going to initially rise here. And then halfway between pi over 2 and pi is 3 pi over 4. All right, and at 3 pi over 4, we're going to hit the max. All right, and the max is determined by the amplitude added to the midline. So the midline here is 0, the amplitude is 3, so we add 3 to 0, we get positive 3. So that'll occur at 3 pi over 4, 3. And then halfway between pi and 3 pi over 2 is 5 pi over 4. All right, how can technology help me get that? Well, again, ignore the pi. So I'm adding pi, which is 1 pi, plus 3 pi over 2, which is 3 halves. Enter. All right, and then I'm dividing that by 2 to get the number in the middle, and then changing that to a fraction. All right, and then sticking the pi back in the numerator. All right, so that's how I'm getting that midpoint. Just left number plus right number divided by 2, and then stick the pi back in. All right, at that point we are going to be at the low point, which again would be 0, or the midline, minus the amplitude, so minus 3. So this has a height of 3, this has a height of negative 3. These are the y coordinates, by the way. The x coordinates are 3 pi over 4, 3, 5 pi over 4, negative 3. So there would be one period of this sine wave. And again, it would do it again all over again. The period is pi. Again, 2 pi divided by this 2 right here. So add pi to all these numbers. Add pi to pi over 2, you get 3 pi over 2. We'd start the sine wave again. Add pi to 3 pi over 4, you get 7 pi over 4. We'd get to the peak. Add pi to pi, you get 2 pi, and we hit back to the x-intercept. You could, again, make as many of these as you want just by adding the period to those first 5 points. All right, there's my altered sinusoid, 3 sine 2x minus pi, like it says there. I'm going to hit window. My x-min this time is pi over 2. That's where my period begins. I'm going all the way to 3 pi over 2. All right, this is, again, a period of pi, so divided by 4, I'd get pi over 4 is my step size. All right, I only go between negative 3 and 3, so I don't need negative 10 to 10. I'm going to just do negative 4 to 4, just to have some space on the top. All right, then graph. So there is one period of this function. All right, if you want to see more, you can change your window, go out a little further. So 0 to like 4 pi or something. If you need to see more than one period of it. But you can see that this is much tighter. There's 0 right in the middle would be 2 pi. You see this is much tighter than the regular sine graph that we're used to seeing. All right, so again, so same 5 points like we did for the sine curve. It's just we have to find our new starting point and our new stopping point. And then, again, if you're using my method, you're dividing by, you're splitting these in half, getting the midpoint, and then splitting them in half again. All right, now we'll look at one for cosine that has a little bit of everything. What I mean by that is we have an amplitude adjustment. We have a period adjustment. We're going to have a phase shift and a vertical shift. So this has everything that you can ask for in a problem. All right, this is my original left-hand side, my original for cosine. It's originally at 0, 1, and then it's originally, that should be 2 pi, and then it's also back 2 pi 1 when we do a cosine graph. So this is, again, the original period, 0 to 2 pi. Now I'm going to solve this for x in both of these to come up with what's my new left end, what's my new right end. So there is my new left end, just solving that for x. I get negative 3 pi over 2. There is my new right end, negative pi over 2. Okay, negative 3 pi over 2. What did I add to get to pi over 2? I added pi. All right, and you can, again, get this from taking the upper number. So negative, don't put the pi in there, so negative a half, minus, leave off the pi, negative 3 pi over 2, or negative 3 halves, enter, that's 1, stick the pi back in. So that's the period of pi between those. So there's my number line. My new left end is a negative 3 pi over 2. My new right end is negative pi over 2. All right, after you get that, you want to get your midline shift. Okay, so our midline shift is negative 1, so instead of it being the x-axis, we're going to start from the line y equals negative 1. So I'm just dashing that in here. This is y equals negative 1. All right, and remember, cosine, the the cosine function starts off at its max and it falls from its maximum, right? If this were negative, we would start off at our minimum and rise, but we are positive, so we're going to start off from the max, okay? The max is, for regular cosine, is 1 unit above the midline of 0, but now because we are starting off, we have a 4 out here, we're going to be 4 units above our midline of -1. So -1 plus 4 is 3. So we're going to have a max here at 3. I'm going to put a little dot, and I'm going to say that height is at 3. All right, and that 3 is just 4 minus 1, or -1 plus 4, however you want to think of it. All right, so one full period away, we'll be right back where we started. So at 1 period, we'll be back at 3. Halfway in between these, all right, again, -3 halves, -1 half. Halfway between those will be -2 halves, or -pi. And a negative pi, if we're cosine, we're at the opposite where we are at the end. So if we're at the maxes, a negative pi, we're going to be at the minimum. All right, the minimum here is -1 minus 4. So it's going to be way down here at -5. All right, and then we come up with the halfway points again. So what's halfway between -3 halves and -1? What's halfway between -1 and -1/2? So again, you can do it with your calculator. So -3 halves, again, I'm ignoring the pi, plus -1. Divide that by 2, that's the number in the middle. It's the average. Math, back into a fraction, stick the pi back in there. So -5 pi over 4. Right, and then halfway between these, -1 plus -1/2, enter, turn it into a fraction, stick the pi back in there, so -3 pi over 2 is that point, okay? And those are, again, the halfway points between the first and middle, the middle and last. Those halfway, those quarter points are midline intercepts, not x-intercepts, but midline intercepts. That's where they cross the midline, which is, again, y equals that vertical shift. So there's those midline intercepts. So this cosine function, this is going to look kind of funky because I'm doing this with a mouse, would look something like that. That would be 1 period of this altered cosine function. All right, so I got all that in there. I'm going to do my window between -3 pi over 2, -pi over 2. All right, and then my period, again, that whole period from there to there is pi units. So I divide that by 4, I'd get a pi over 4 is my step size. All right, my low number is -5, my upper number is 3. So I'm going to do those two just to see that it's very tight against that, and then I'll graph it. So there is 1 period of this cosine function. All right, but sometimes you'll be asked not to graph it in the negative. You know, your shift will push us back into negatives because this is these numbers are positive, so it's actually shifting us to the left. And this number right here, I should say, is positive. So it's actually shifting us to the left. So we're, this point is now to the left of the y-axis. So a lot of times they'll have you come up with what would it look like 1 period for positive values, or between 0 and 2 pi, and or starting between 0 and 2 pi. And if that's the case, you would have to take the period, which is pi, and add pi to all of these numbers. So if I add pi to -3 pi over 2, I'd get to this -pi over 2. That's still not technically there, so I'd have to add another pi, and I'd get to +pi over 2. And then adding 2 pi to this, adding 2 pi to this, and that way you'll get 1 full period in the in the positive angle window. All right, then something that we do often to model data. Data just being a collection of points. So I got a collection of points. These are months since January of some year, and this is the average temperature in Denver. And we're plotting that, and because the world spins around the sun, the average temperatures fall into this periodic pattern, and a sine wave kind of models it very, very well. And so what we end up with is needing to come up with these values for alpha, omega, phi, and b, or beta, I guess, A and B, and then alpha, or omega and phi. But to do that, what we have to remember is what each thing does. Like A, the value of A, that's the amplitude. So that's the distance from the midline to the peak, or the midline to the valley. But what we could do, since it's the difference between the midline and the peak, we could find the minimum value, the maximum value, and average those, and that'll give us a pretty good idea. The amplitude. So the largest data value minus the smallest, that'll give us the total gap between the max and the min, and then dividing that by 2 will give us halfway with it. So that's basically the amplitude. So we know we're going to have a 22.1 in front of the sine function. Now, the next thing we want to do is find that vertical shift. So you can see that right now we have, it's, you know, we have an amplitude, okay, we're covering the top and the bottom, okay, but we need to fix the period, we need to fix the midline, we still got a lot of work to do. So the next thing we're going to do is find the midline, and the midline we can find by, instead of subtracting largest minus smallest, we add them together and divide by 2. That'll give us the average, and that's the number right in the middle between the largest and the smallest. So in this case it's at 52.1, so now we know we're going to have the sine function times 22.1 to fix the amplitude, plus 52.1 to kind of get us in the correct range. And so you can see now we're hitting the max, we're hitting the min. Again, our period is off, so we got to fix the period and the phase shift as needed. All right, because there are 12 months in a year, and we're doing average or monthly temperature, the average temperature for each month, we're just going to take the period formula, 2 pi divided by that omega that we put in front of the x, and we're going to set that equal to 12. We want it to cycle every 12 months. So we do the math and we get a pi over 6 is the value for omega. So now we know it's got that look, 22.1 sine pi over 6x plus that vertical shift. All right, and you can see that now it's kind of got the right spread to shift, you know, to cycle through the months correctly. It's just we're starting in the wrong height, and that's the phase shift. That's where the phase shift comes in. All right, so to get this part right, the x that we're dealing with here, we're going to think of it as, you know, already been adjusted. The period's already been adjusted. So our period is 12, and so, you know, if you think about the quarter periods, this is 0, this is 12, this is halfway at 6, okay, and then this is at 3, this is at 9. So 0, 3, 6, 9, 12. And you can see that we have our data points. If you go back and look at them, this is 1 is January, 2, 3, 4, 5, 6. You can see our peak is taking place in July. So that's at 7. And again, right now, because again, halfway is 6, this is 3. Right now, our peak is taking place at 3. We need our peak to take place at 7. Again, you can count that 1, 2, 3, 4, 5, 6, 7. So we need this peak to be from 3. Again, it's at 3 right now. That's x equals 3. It needs to be over at 7. So that means we need to move to the right 4. So that means we need to replace x with x minus 4. That will move us 4 units to the right. So we're going to replace that x there with x minus 4. So temporarily, it's going to look like that. And then we just distribute this pi over 6 through. So pi over 6 times x. Pi over 6 times negative 4 would be negative 4 pi over 6, and that'll reduce to negative 2 pi over 3. So there is our function that will model this. And you can see after we do all that, it does fit pretty well. Not perfect, but it fits Fits pretty well, especially on that backslide coming down from those peak summer months. All right, then there is a something called a regression feature in Desmos. So let me show you how to use it. You can press the Stat button here, go to the editor, and enter in this data in the L1, L2 columns. I'm going to clear out, just press clear, don't hit delete. Here, press clear, enter, go over to L2, clear, and enter. And now I'm going to enter in these values, 1 through 12. And now I'm just putting in those temperatures that correspond to the month. All right, so once I have that in there, I'm going to press the Stat button again. Stat, go over to Calc. And then these are where it says REG, those are called regressions, which is like curve fitting. And I want to go down until I see sinusoidal regression, which is just going to say sine. All right, so there it is, SIN, sine regression. All right, I'm just going to do one iteration, L1, L2. I'm not going to tell it a period, I'm going to tell it to come up with a period. Store regression equation, I'm going to tell it to store it in Y1. And the way that we do that is we press vars, V-A-R-S, yvars function, and then there's y1. I'll press calculate. All right, so there is what it came up with. I'm going to turn my stat plotter on. I'm going to go to y equals. Plot 1 is off right now. I'm going to go up and press enter, turn it on. Now it's got that block around it. And then I'm going to press zoom. And then if you look at option, scroll down to option 9, it'll say zoom stat. It may be a different number for depending on which calculator you're using, but I'm doing zoom stat here. So there's my sine curve, and there's the curve that comes in and fits it. And it fits it very, very well now. All right, so there's that sine regression that it's talking about, showing those same numbers that we got, and then that plot of the sine curve. Again, same type of plot that we got. Just some little discrepancies in the numbers. I might have typed in a data point wrong. But anyway, there's the process, the procedure. So you can see it has that same format, something times sine, something times x, plus or minus a number, plus or minus another number. And that's what we're doing here when we do this type of curve fitting with our calculator.